All right, so we're going to switch to the digital device, the digital oscilloscope. The biggest advantage of this thing is if you look here, you're going to see when I go to this measure anyways, if I can hit the button while I'm standing there, it's going to have all these different assignable tasks that we can put on there. And one of the things I can put in there, I can put voltage peak to peak, I can put frequency, I can put voltage RMS, I can put any of those things I want to in there that's available on their drop-down screens. So that's the beauty about a digital scope, is you have assignability. You may need to get closer to see what's going on with this thing. That's the best picture I could get on the overhead projection. On my computer, it looks pretty good. But anyways, if you look at the scope, it's got the same kind of sections that you had before. It's got a vertical section. It's actually got two vertical sections. So that's going to be just like it was before, except it uses soft keys. It's got a horizontal section over here, and then it's got the trigger section. So the functionality you had in those four components on the digital scope are still here. It's just that you're going to get to them a little bit differently. One of the really beautiful functions that I like on this thing, let me screw up my signal a little bit, is there is a little up here that says, I think it's acquire. If I do acquire, nope, that's not it. Which one was it? That's pretty bad to start off. And I can't remember where the, auto set, that's the one I wanted, the auto set. It will go out there and it'll look at the signals and it'll give you the initial settings to use, which works pretty good. The other way you were trying to figure out what the period was and kind of calculate what it needed to be to see it and the peak. I can just hit the auto set feature up here and be able to get that. Okay. So I've got two different signals on here for right now. I'm gonna get rid of one of them. I'm gonna bring this guy down. And then I'm going to change the scale because I don't like that scale. I want to have a bigger scale so that I can always maximize my vertical and my horizontal. Okay. So let's talk about what's going on here. Let's look at this vertical scale here for the first thing. It's got the position knob just like you had before. I can go up and down. I probably need to do that from the other side so I'm not breaking it. So I can do it up again. Notice this little arrow. That is the center line. Whereas in the other one, you had to go ground to put it in a place. I can just move that down to that little arrow for channel 1 is lined up for where I want to have it centered at. Okay, nice little feature. Does the same thing on channel 2. If you look at this thing, there's a channel 1 menu. So when I push that, let's put it in another menu here for right now. We'll go back to the measure. So I'm in another menu. So when I'm in this and I want to control something that's on this channel 1, I have to hit the channel menu. So I hit the channel menu and notice these soft keys have just changed definition. Here's the key that's associated with the AC coupling. Remember AC and DC coupling? So I can toggle through that. I can ground it, put it in DC, or I can go back to AC. It has remember the bandwidth, the little filtering. I've got a filter setting on this side. So I can turn on a 20 megahertz filter or turn it off. The other one, you had a setting that you could do that. Not a setting, but someplace on here was that filter setting. Anyways, I have a volts per hertz division. I can have that in coarse or in fine. Don't use fine, use coarse. But what that's for is to change the scaling. Remember on the big dial, we can change the scaling. I change my scaling here, and where it shows up is channel 1. It says channel 1 here, and it says right now it's 2 volts per division. I know you can't see that, but if I change it, I'll bet you see it change.
So you don't have to manually count the divisions?
You do not? Well, depends what you do. So anyways, when you change it, it's going to change that thing. Use the coarse because that'll be equivalent to the settings you saw before. If I use the fine, it's only going to change it. Like you may go 2.1, 2.2, 2.3. It's not worth doing that. Okay. If you get in here and this thing is set on a 10x probe, you'll have some screwy readings. So you'll always want to make sure this is set at 1x probes. So it's going to be measuring 1 times the digital signal that it's reading in terms of the voltage. All right. And then there's this invert, just like there was on the other one. I can invert the signal and go on. Okay. So that's channel 1. I have the same exact controls for channel 2. If I push channel 2, my signal that's on channel 2 is going to show up. I can raise it. Notice the little arrow on the left-hand side. Raise it to center it. So now I've got both of those across the 0, so I can look at them both at the same time and compare them. This was channel 1 voltage per division. Here is channel 2. So I'm going to change that to be the same as the other one. That's not a good sign. There we go. Well, I'm just going to leave it at 5 volts. Because that should be a different value, I think. Oh, I changed the frequency. No wonder. Anyways, I got the same exact controls are signed to this soft keys, but it's for channel 2. If I don't want to see channel 1, I hit it a second time, it goes away. I hit it again, it comes back. Same for channel 2. Hit it twice, it'll go away. If I hit the button without it moving, hit it again, it comes back. Okay.
Does this one, the digital oscilloscope, does it do can you do subtraction of the 2?
In there.
Okay, sorry.
Getting there. So the other function that's in the middle, you can't read that, I'm sure. That says math.
Oh.
Okay. So I'm going to take my math and notice a third signal shows up. And if I can't tell what I'm looking at, I can get rid of channel 1. I can get rid of channel 2. And what's left is my math channel. And that's the difference. Right now it's set up. Let's go back to the main math menu. Right now it's set up as channel 1 minus channel 2. Some of these things will have more functionality than that. This one's got channel 1 minus channel 2, but you can have different operations. There it is. I can take a fast Fourier transform. We won't do that. I can add them and subtract them. All right. So
You can't multiply or divide.
Can't multiply or divide. But you can do a fast Fourier transform, which is what you would use on communication systems to look at frequencies. Okay. I mean, all the signals, all the frequencies that are present on that frequency. But you have to go to math mode to be able to do that.
I think awesome. Why would you ever use an analog?
Because you don't have a digital.
Yes, we do. We have a
Because
bunch
in the
of
real
them.
world, you may not have a digital. Right? You may have, because they're considerably more expensive and not all labs are set up to the latest and greatest technology, right? Some of them may still be using,
How was that?
what's a voltmeter, volt-ohm meter. You should have learned how to read that in DC.
We never used that in DC.
Okay. Anyways, going on with this, I was going to show you, remember how we had to have these things, got to have these things on the same scale to make this work properly. I'm going to leave this just the way it is because I changed the frequency and the voltages are about equal. But one of the things you can do with this is instead of having to count the boxes, I can use what's called a cursor control, and that cursor control is up here. I go to the cursor control mode. I'm going to turn it on, and I can choose between a voltage, measuring voltage, which is on the vertical scale, or I can measure time across the horizontal scale. Okay. So let's say I want to measure the voltage on this thing. I have to make sure I'm looking at the math channel because you can look at channel 1, channel 2, different reference signals, but I want to make sure I'm looking at my math channel. And then I can take my cursor buttons that were here for the vertical, and I can, using the wrong, okay, this is the one on the top. I'm going to set it all the way up here. I set it about midline on that waveform there. And I go down here and I put it midway in the waveform there. You're going to have a delta. Usually this will tell you voltages, but because I've got this on different scales, it's just 400 units. Let me go back to what I had. Let's see, what was that? That was somewhere around down here. And now I'm going to put this guy back on the. All right, now they're on the same voltage scales. So now I'm going to do the math channel again. I'm going to get rid of those guys so they don't confuse you. The signal, notice the resulting signal has got a little M out there on that little tick that's on the left. So that's one way of telling what it is. But if I go up here now and do the cursor control,
What does that mean?
M for the math.
Oh, okay.
At least that's what I think it is. It may mean something really obtruse, but that's what I think it means. So now I measure that signal and it tells me the difference between this line and that line is 1.76 volts. I don't have to count and multiply. Okay. It
I
tells
thought
me
they were the
cursor
exact
one is
same.
setting at 720 millivolts, cursor two is at minus 1 so it just does that math.
I thought they were the exact same.
Huh?
I thought they were the exact same. 1 and 2.
I changed it.
Oh,
I changed the frequency so that they wouldn't be the exact.
oh, okay.
So I got a little bit of difference there. Right, if you look at this thing now, if I go back and look at channel 1 and channel 2, notice there's a phase shift and the one's a little bit smaller. I just changed the frequency to drop the voltage across the capacitor a little bit. Okay. But that's the vertical controls. Pretty slick. I mean, you can do a lot of stuff. Here's one other thing you can do. Now I can go up here and do this measure function, which is this button here, measure. I click on that one. And it says anytime I hit the measure, I'm going to get this assigned because that's the measure cursor. I mean, the measure menu. Now I can assign whatever I want to on this thing. So let's say I want to choose channel 2. The first one I want to say, I'm going to have that to be on channel. I want that to be channel 1. And what I'm going to measure is, what am I going to measure? I want to measure voltage. Peak to peak voltage. Okay, that's going to give me that value. Right now, the value is 13.7. If I want to go to, let's go back so that they're all displayed. So now you see up in the upper right hand corner, it's giving me the voltage on channel 1 and peak to peak. What if I wanted that to be instead of channel 1, peak to peak? I want it to read RMS. There's the RMS value. Okay, that's got a question mark on it because my frequency is just off the page a little bit. Anytime you see a question mark, it means you have to widen your scale up because it's not seeing enough of the size of the waveform to be able to do that. So that's 13.8 volts or 13.6 volts and 4.68 volts RMS. Now, if I want to see the frequency, just say that's channel 1 is going to be the frequency. I'll just leave it at that. Originally, I had this thing dialed in at 5K. So I'm going to dial this thing way back. Whoops, go the other way. I ran out of space, so it says you're too big. So now if I want to set this thing at 5K, I guess got to be patient enough for this thing to do its job. I can dial that in without having to count any of those. There we go. So now I know my frequency on my wave check generator is at 5K. I don't have to measure the period. Take one over it, do the calculation, and then make sure I got that exact period. I can just dial it straight up.
So you do the inverse of what it says up there?
Say that again?
You take the inverse of what it says up there?
To find what the period? That would be the period, but if I want to see the period, let's go down here. I want that one to be the period. So now I have both the frequency and the period. Everything in the circuit is going to have the same frequency or period. So for channel 2, maybe all I care about now, the only thing I need to have that's different is the voltage. I'm more concerned about peak to peak. So down here, I'm going to go change that to channel 2 and make that the peak to peak voltage. All right, so now I've got, anytime I kick my measure up, I can see what the value is, channel 1 peak to peak, its RMS voltage, its frequency, its period, and then the peak to peak value on channel 2. So I no longer, again, don't have to count all that stuff. The only thing I don't like about the picture that's displayed there is it's not wide enough. I want to maximize that so it can do it has the same problem your eyeball does. It's physically looking at that screen and using a digital processor with the screen image to figure out what those things are measuring. Okay. So you always want to maximize it. Maximize it so you don't get any question marks out there. So there's other stuff up here. There's display functions, acquire. Really, the only two you're going to use for most of the time are going to be measure and cursor. You use the cursor when you're in math. I remember that because everybody likes to curse when they do math. So cursor. The measure is when you're looking at anything that's connected to channel 1 or channel 2, direct measurements. Okay. Again, when you use the math, you got to make sure those are both set on the same scale, just like you did with the other one. So let's look at the horizontal.
Scale, same Hertz.
Pardon me?
The same scale, the same Hertz,
Same volts.
same volts.
Vertical channels 1 and channel 2 are the vertical channels are volts per division. Horizontal is the time scale. That's what we're going to talk about now.
So, but those aren't the same volts and you're measuring them.
I don't understand the question. Of course, they're not the same.
You just said that channel 1,
No,
channel
no,
2
no.
had to be the same.
Channel 1 and channel 2 have to have the same scale setting. That's what I was pointing to.
Oh, okay.
The scale setting, this 2 volts
I got you.
and that 2 volts, they have to be set on the same scale, just like they were with the analog.
So the multiplier is.
Yeah, so that you can do the division or the not the subtraction. Watch what happens to the math channel. That's this guy here. If I set one of these guys on a different channel, I didn't change the signals coming in here, but I just jacked up the math went different. All right. So you always want to have those guys set on the same scan channel or the same scale. All right, let's talk about the horizontal. So the horizontal's got the same type of controls. I can position this just like I did before. I can, there's the horizontal menu. So if I want to look to do anything special on this one, just like I had on this guy, for the other guys, it's soft assignable. So let's look at what the horizontal menu is. There's not much you're going to use here. In fact, I never use the horizontal menu. It's asking for a window zone. If you want a picture in a picture, you can do that. Don't mess with it. You'll get confused with it. You can change the size of the window.
That screen's way too small to do picture in picture.
I agree. That's kind of why I don't use the window zone. We're trying to do smaller things. But you got this thing to be able to do level and hold off. Those will all stay the way they are. But let's go back. We'll go back up to the measure. But now if I want to go and change the scale of the horizontal scale, I change it with this knob. It is displayed right here. So that tells me what the scale setting is. In this case, it's 25 microseconds. So I set it to 10. Notice when I went to 10, all my values, except for one peak to peak, basically went to question mark. That means my signal is off the screen. I need to go somewhere smaller. It'll take anything smaller, but you might lose some accuracy in your measurements when you do that. Okay. So there's not much to the horizontal. Yeah, it's measuring time, and I can display with my measure button the frequency and the period, which were associated with what you had to do on the other stuff. Okay. Last one's going to be trigger. Again, there won't be much that you can do on this one, but with the trigger, there's a knob there's a little one of those tick marks over here on the right-hand side. What this is going to do is show you where your trigger is actually at. Notice as I move this thing, it's shifting it. If I get above the highest level, my picture goes unstable because the trigger point is set higher than my biggest signal. It doesn't know how to track it. So if you get garbage like that, find that little cursor and bring it back down, put it someplace reasonable. I usually just leave it set at 0. You've got some other capabilities here. Let's do the trigger menu. I can set the type that I want to have. This is set, it's going to be edge, but I can set it to do a video signal, a pulse, or the edge. The other ones were set on edge. We're going to leave this on edge. We can tell it what to look at for its syncing source. This is going to look at channel 1. That's because I'm always asking to put the voltage source on channel 1. We want to trigger off of that one. We know we're going to have a signal there. And then the slope, I can do it on the rising edge or the late falling edge. Leaving it on the rising edge. We can do the mode as auto, normal. There's not much difference between those guys. If I got something that's not syncing when I've got it in the range, I usually go ahead and try the other one. But I would typically just leave this in auto. And then this DC coupling, noise reject, high frequency rejection. Again, usually I'm going to leave that in AC coupling. There's some other buttons in here that are for presets. It'll set at the 50% level. It'll force trigger. It'll force it to find a trigger point if you push that button. You won't need to mess with those stuff. So the main things are going to be using your measure button after I've done another menu to get that measure thing up so I can take my measurements. Right? But that's the beautiful part of this. And then when you're in math mode, I can't read them off of this. I have to go to the cursor mode. And in this case, I'm going to make that with voltage. Oh, I wanted to show you this. Let's do one of these in the time mode. So if I wanted to measure the period of this thing, what I can do is now if you look, these two cursors that we had before, whoops, I'm not doing it yet. Why am I not? I got to go back to the cursor mode. Now, if I look at those, they're moving left and right. So I can cross one there, cross one, second one over here where it repeats. And now this thing will do the calculation. Let's say that's 196 microseconds. So that would be the period, which is 5.1 kilohertz. And I didn't set those very accurately. I just kind of set them close. But you can measure any distance you want to on there, okay? Which will be useful when we try to measure the phase shift.
So will this also capture the frequency, or do we have to do the
This will do what?
for the frequency? Like if we set it on the thingy, like will this know what it is?
If you hit this auto set button, it will give you a starting place for the frequency. The only time that won't work is if you've got really low voltage signals on your power supply coming in, because it'll look like noise and it'll try to sync with noise. So if you use that and it doesn't work, it means you don't have enough voltage on here. So turn your voltage up a little bit so you can get it to start, and that should make it happen.
I couldn't see what you were moving there.
Oh, okay. Let me point to them. There's two cursors. Our cursors that were out there before were horizontal lines. Now they're vertical lines. So if I move this one, I can move it to a crossing point.
Oh, okay.
And let's say I just wanted to measure to that period there, and not, I can find out what the distance is in seconds, or I want to get the frequency when it repeats. I can go out there and it's 202, or it should be around 200. I just haven't got it exactly where I need to have it.
Okay. So when you're in the cursor mode, these are what move.
There's two cursors that move. This is for the time version. For the voltage version, they move up and down, but they're the same buttons.
Oh.
Okay.
Okay.
All right. That's very useful when you're in a math mode. Just about anything else. The other place that's really useful is if you've got a signal that's bouncing around a little bit. You know, I may be on this measure, and when I look at this thing, I got to turn channels back on. Go back to measure now. Sometimes because of the noise, you're measuring lower voltages, so that's bouncing between 3.7 and 3.8. Not a big deal. But if I'm measuring millivolts, I may get something bouncing between 0.248 and 0.89. Well, if I want a stable number, I can use the cursor and position it, and it'll put it in the middle of the noise band that's on each one of those things, and it'll be good. All right.
is the third graph, the difference between channel 1 and channel 2?
It's the graph, the difference between.
Yeah, the third one, because we have three.
Oh.
Graph.
This,
Yeah,
that's the difference. Because I had that on the math mode. If I get rid of the math mode, click it twice, it goes away and I'm left with this channel 1 and channel 2.
Yeah.
If I click channel 2 twice, it goes away and I'm left with channel
it
1.
means I will use that to measure the voltage for my phase resistance.
That's what you're going to use to do the difference method like you did on the analog. Okay. All right. Well, I'm going to turn this thing off and let you guys do your lab.